Now we are going to see the flight controllers for the quadcopters. There are many different types of flight controllers are available in the market. So depends upon your application, we have to select the one. So the cheap and best one is ArduCopter or ArduPilot. Here you can see. So these boards are called APM boards. APM in sense ArduPilot Mega. So these two boards are compatible with Arduino software. It contains Atmega 2560 as microcontroller. Now coming to this board, this is APM 2.8 version and this one is APM 2.6. So the main difference between 2.6 and 2.8 is all the hardware is same, but compass will not present in the APM 2.6. So there is no compass, we have to connect externally. So this is the GPS compass module. So this is for compass and this is for GPS. So here you have to connect like this. Here you can see the indication for the GPS. So why we are going to use GPS for this board is, this board has a pretty feature, that is return to launch. Means if you don't know how to operate the quadcopter while in the air, simply you can select return to launch feature, so that with the help of this GPS the quadcopter will return to the home location. So while takeoff it will store the home location, latitude and longitude points values, and finally it will fly. Whenever you selected return to launch feature, it will again come to the home location. So for APM 2.8 there is inbuilt compass. By using that compass it will know the direction. So if you want to connect external compass, you have to remove a jumper from these pins. So here there is no jumper, means I have to connect external compass. If I want to use internal compass, I have to put a jumper. And coming to inputs and outputs of these two boards, input side is connected with the receiver and output side is connected with the ESCs. So first we will see the output side. So we are having 4 connectors from the ESCs. These 4 are connected to the outputs of the flight controller. So this is how you have to connect. So always black is negative and the last line is negative and middle one is positive and the upper one is signal wire for the ESCs. So you have to connect like this. So by using this board we can make octocopter, up to octocopter, means we can control 8 motors. Here we are going to use only 4 motors. So later we will see how to configure this board for a quadcopter. So this is how you have to connect the ESCs to the board. So the power supply for this board can be taken from either ESCs or from the power module. Say for example, if you are using a power module as power source, you have to remove the jumper here. If you are taking power from the ESCs, 5 volts power from the ESCs, you have to use this jumper. Here I am going to take power from the ESCs, so that's why I am going to use this jumper. So for every configuration, you have to connect the motors in right way. Means coming to H configuration, this is the first motor and this is the second motor and this one is the third and this one is the fourth. So first motor should connect it to the first and this is the second motor. This second one should connect with the second. Similarly for third and fourth. If you take X configuration, this is the first motor, this is the second and third, fourth. Coming to the direction of rotations, it may change from X and H. So for H copter, these two motors are going to rotate in clockwise direction, and these two motors are rotating in anti-clockwise direction. So these two are for clockwise and these two for anti-clockwise direction. So if your motor is rotating, this motor is rotating in anti-clockwise direction, you want to rotate in clockwise, simply interchange the any two wires. Say for example, this motor should rotate in clockwise, but this motor is rotating in anti-clockwise. So to change the direction of this motor, we have to interchange any two wires so that the rotation will change. So the main goal of this flight controller is to make the quadcopter stable in the air. So coming to the features of this board, it contains internal gyro sensor and accelerometer. So these two sensors are responsible for the stability of the quadcopter in the air. So for example, assume that I have connected my APM board to the quadcopter, and this should be facing in the front direction. So this is the front direction for the quadcopter. So after flying some height, if the quadcopter orientation changes, immediately the sensors present in the flight controller board will detect the orientation, and finally they will speed up these two motors, and like this the flight controller is going to make the flight stable. Similarly, if the flight tilt like this, the sensors are going to detect the orientation, and finally they will make the copter stable. So this is the main aim of the flight controller. Other than this stability, it is having some other features like altitude hold. So whenever you select altitude hold, the copter is going to maintain a certain altitude. And return to launch, if you don't know how to operate this copter in the air, simply select return to launch so that it will come to the home position. Like that, a loiter, it is also very similar to the position hold, means you can stop this copter at any point in the air. Means say for example, the copter is at this level. At that time I want to make this copter stable. For that purpose, simply I will select position hold. At that time it will hold at this position until you remove that position hold mode. So now coming to the inputs, we have to connect a receiver. Here we are going to use a 6-channel transmitter receiver. We will see it later how to configure that 6-channel transmitter using a T6 config software. And these two are used for GPS and compass I2C. And these are optional pins where you can connect a buzzer, LED and some other things. And this telemetry is used to send the flight data to the ground station or a laptop. By using the telemetry, you can send the data of the flight. So this one is the USB, where we are going to configure this entire board using this USB cable. So the software used to configure the APM is Mission Planner. By using the Mission Planner, we will set all the things which are required for the flight controller. Means we are going to calibrate the flight controller. We are accelerometer present in the flight controller and also compass, and finally we will select the frame. If you are making an octocopter, we have to select the octocopter frame. If you are making a quadcopter, we have to select X or H, like that. All the configurations are done in the software, and finally they are saved in the flight controller. Coming to one more board, which is a beginner board, that is KK board. So this is the KK board, which is having inputs and outputs like APM. So here you can see this is output and this is for inputs. So output side is connected with the motors and input side is connected with the receiver, and this is used to connect the buzzer, and this red one is used for the battery. So whenever you connect the battery here we will get the current voltage of the battery. So every microcontroller has a software or a firmware running in it. So to update that software, we are going to use these pins. So this is the LCD display. So here there is no USB cable. So by using these buttons, you are going to configure the flight modes and other things present in the board. So by using this board, we can make tricopter to bicopter to octocopter. So all the things should be selected in this board by using these 4 buttons. So here it is not having a return to launch feature, altitude hold feature. The main goal of this board is to stabilize the quadcopter in the air. So this is very beginner board which requires lesser knowledge to configure this one. First we will make a quadcopter using ArduPilot, that is APM 2.8. Then we will see KK board quadcopter.